So we are dealing with the fifth problem in this segment, and the fifth problem is problem number 1.29. If we consider this problem, the problem is stating a body is thrown from the surface of the earth at an angle alpha to the horizontal with the initial velocity v0. Assuming the air drag to be negligible, find the time of motion, the maximum height of ascent and the horizontal range, at what value of the angle alpha they will be equal to each other. And the last part is asking us the equation of trajectory where y and x are displacements of the body along the vertical and the horizontal direction respectively. So if we start approaching this problem, let us first begin by understanding that we are technically trying to derive the important results for projectile motion. So I am constructing two xy planes for better understanding of the problem. So if we construct this, we are stating that this is x-axis, this one is y-axis. The body is thrown with a velocity v0, making an angle alpha to the horizontal, and post which the particle is following a path like this and will end up somewhere here. And over here on this side we are trying to depict the same situation, but at a certain instant of time. So at a certain instant of time, if we consider this same projectile projected with a velocity v0 making an angle alpha, and it is following a path like this. So at this particular instant of time, say at a point P, the displacement of the particle is x in the x-axis direction and y in the y-axis direction. So these two diagrams will be helpful in solving the entire scenario which the problem is going to discuss. So for the first part, we are considering that we are breaking down the motion in the x-axis and y-axis direction respectively. So we will be discussing about along x-axis, and then on the other side we will be discussing along y-axis. Since projectile motion is an example of two-dimensional motion, both the motions are taking place simultaneously. This must be kept in mind. So initial velocity in the x-axis direction is equal to v0 cos alpha. Acceleration in the x-axis direction is 0. Displacement in the x-axis direction. So if we talk in terms of the total duration of motion, so the motion starts here, which we regard as the point of origin, and it will end here, which we regard as r, 0. Somewhere in between it will attain a maximum height, which we are referring as in the y-axis direction is hm, or the maximum height. So along x-axis, the displacement along x-axis can be considered that initially it was at a 0 mark, and then finally it is at r, 0. So displacement along x-axis is r, and this entire motion happens in a time t. If we talk in terms of y-axis, initial velocity in the y-axis direction is v0 sin alpha. Acceleration in the y-axis direction is minus g. Negative sign is representing that the gravity is acting in the downward direction. Displacement along y-axis, so in the entire duration of motion. So whenever I am saying this, I am repeating over and over again that we are discussing about entire duration of motion. So in the entire duration of motion, initial coordinate of y-axis is 0 and the final coordinate of y-axis is also 0. And then again we are talking about the situation at a time t. So if we solve the equation of motion along y-axis, so we say displacement along y-axis is initial velocity along yt plus half acceleration along yt square. So displacement along y-axis is 0, v0 sin alpha t minus half gt square and on solving we obtain t is equal to 2 v naught sine alpha by g. So this is the part 1 answer. This is the answer to the first part which the problem is discussing, the total time of flight. So the total time of flight during this motion is equal to 2 v naught sine alpha by g. Now the next thing is maximum height of ascent and the horizontal range. So for maximum height of ascent, so if we discuss this part, we say at the point of maximum height, the velocity in the y-axis direction, instantaneous velocity in the y-axis direction becomes 0. And for calculating the range, we can say if we solve the x-axis part of the expression, that displacement along x-axis equals initial velocity along x plus half ax t square, then we can calculate r equals v naught cos alpha times t. And if we connect both the expression with time, that is the duration for the x-axis motion and the y-axis motion is same, so we get r equals 2 v naught square sine alpha cos alpha by g, or we can write it as r equals v naught square sine 2 alpha by g. So this is the answer to the second part of the problem, and second part's first part problem, that is range is asked in the problem. For y-axis, we are again solving along y-axis, that instantaneous velocity in the y-axis direction is 0 when displacement along y-axis is h max. So we get v square equals u square minus 2g hm. So hm is equal to v naught square sine square alpha by 2g. So this is the maximum height attained by the particle during its projectile path. Now in the second question it is also asked when the range and h maximum will be equal. So once we have the expression for range and h max, the only thing we need to do is we need to equate them for r equals hm. So for r to be equal to hm, we can say 2 v naught square sine alpha cos alpha by g equals v naught square sine square alpha by 2g, and on solving we obtain tan alpha equals 4. So we can say that the answer is tan inverse 4, or roughly 76 degree. So alpha equals tan inverse 4, which is roughly 76 degree. This is also the part of the problem that we have. So this is the answer to the first part A, and these expressions are the answer to the second part of the problem. And now in the third part, the problem is asking us to write the equation of trajectory where y and x are the displacement of the body along the vertical and horizontal direction. So for this, let us come back here to this diagram which we have constructed earlier, that at a certain instant of time t, the particle will undergo a displacement x in the x-axis direction, and in the same duration of time it will be having a certain displacement y in the y-axis direction. So for writing equation of trajectory, the first need is that the equation is independent of time. We are considering for equation of trajectory. So at a certain time instant, displacement along x-axis equals v naught cos alpha t. From here we can write t equals x upon v naught cos alpha. And similarly, if we solve along y-axis, y equals v naught sine alpha t half gt square, y equals v naught sine alpha t can be written as x upon v naught cos alpha minus half g t square x square v naught square cos square alpha. So we get final answer y equals v naught tan alpha minus half gx square upon y equal to x tan theta tan alpha minus half gx square upon v naught square cos square alpha. So this is the final part of the problem where it is asking us to find the equation of trajectory. So whenever we are studying projectile motion, these results are going to play a very important role. That whenever we are solving for two-dimensional motion, it is important that we understand the motion along x and y axis. And after understanding the motion along x and y axis, we solve each part independently and then we connect the two expression by time to get the final answer or the required results.